In this video, we will discuss a particular type of random variable called binomial random variables. Now, in many of our problems, it might state, consider the binomial random variable, and when you see that phrase binomial random variable mentioned, it automatically is telling you you can assume this is a binomial random variable. We'll see a formula in a little bit that tells us how to deal with that. But sometimes it might not directly tell us it's a binomial random variable, and instead we need to go through this checklist to make sense of if it is a binomial random variable. So what you see here on the screen is a list of conditions that need to be met if it is a binomial random variable. Let's read through each of the conditions. The first condition is that there's a fixed number of trials conducted. Okay. The next condition that we need to check is that we can clearly identify each trial as a success or a failure. So there's only two options there. The next condition is that the probability of success is the same on each trial. The fourth condition is that the trials are independent. Now, this is a definition we've seen in our previous lectures. This means the outcome of one trial does not affect the outcomes of the other trial. Now, for this condition, we do have a note. If a simple random sampling that we took comprises less than 5% of the population, we will consider the sampled individuals to be independent. So if you know that you have a simple random sample, you know the sample size, you know the overall population size. If the sample size is less than 5% of the population, you can assume it's an independent sample. And then the final condition is that the random variable represents the number of successes that occur. So our random variable x is the number of successes. Now a little bit about notation. In our binomial distribution or binomial random variables, often the number of trials is indicated by this n. And the probability of success for each trial, because each trial has the same amount of probability of success, is p. And then we know that if something is only success or failure, you've only got two conditions. Either it's successful or it's not successful. And those two things together, success plus failure, is all possibilities. And we know the probability that all possibilities could occur is 1, which is why if the success is p, then the failure rate is 1 minus p. Because we know when there's only success or failure as an option, then the probability of success plus the probability of failure is 1, and we can isolate to solve one or the other. So in this next example, we have two scenarios, and we're asked to determine whether it's a binomial random variable. So let's look at this, and as you have your notes in front of you, remember you can always print out our course notes that follow along exactly with these videos. So if you have your course notes printed, just look a little bit above on the page, and you've got our 5 criteria that we just went over. And let's see if the 5 criteria are met for part A. So we'll read it. A fair die is rolled 20 times. Now, whenever they say a fair die, that's just the singular phrase for a dice. And we know when we're thinking about this, this is the 6-sided die, which has a 1 in 6 chance of landing on any of the sides. One side has a 1, one has a 2, 3, 4, 5, and 6. So think about rolling a dice. We roll it 20 times. Let x be the number of times a die comes up as a 6. So let's read through our 5 conditions to see if it's binomial. First, is there a fixed number of trials? That's condition 1 listed above. And we'd say, yes, there is a fixed number of trials because it's rolled 20 times. Okay, what are we considering the outcome? We want there to be a 6 rolled each times. So would you agree if I roll a dice, I'm either going to get a 6 or not a 6? So that meets condition 2, that each trial can only have success, being getting a 6, or failure, getting not a 6. So condition 2 is met. Okay, condition 3 is the probability of success is the same on each trial. Now we know if I've got a 6-sided die, the likelihood that I'll see any side is 1/6. So if I'm looking for how many times I get a 6 and I roll it 20 times, each of those 20 rolls, I had a 1/6 chance. So the probability of success is the same on each trial. So condition 3 is met. Let's look. Condition 4, listed in the page above in our notes, says the trials are independent. Now, every time I roll a die, my previous roll has no effect on my next rolls. So yes, in this case, if I just keep rolling a die repeatedly, that is independent because the previous roll has no effect on the next roll. Now our last condition is that the random variable represents the number of successes, and that is true because for us a success is rolling a 6, and x does represent the number of times we roll a 6. So we've read through our list of 5 conditions and each of them is met. So since each of the 5 conditions is met, we would say this is a binomial distribution. And I just didn't have enough space in the screen to show the conditions, but the conditions I'm referencing are these right here. These 5 conditions. So keeping that in mind, look at this next problem B. A standard card deck of 52 cards contains 4 aces. 4 cards are dealt without replacement. Now what does this phrase, without replacement, mean? Without replacement means that once I deal a card from the deck, I don't put that card back. So originally I had 52 cards, I dealt 1. After I dealt 1, I didn't put it back, so the next time I dealt from 51 cards. Now there's 2 cards on the table. I put neither of them back. So the next time I deal from 49 cards. There's 3 cards on the table now. The final dealing I dealt from 48 cards. So whenever they say you're dealing without replacement, each time you're dealing from a smaller and smaller deck. Now let x be the number that they are aces. So looking at the criteria of the 5 conditions above, go through each of the conditions in order, starting with 1, and see if they all are successful, as in our earlier example, or if one of them fails, which one. And I'd encourage you now to pause the video, attempt this on your own, and then unpause to check your work. So our 5 conditions are listed above. Let's check. First of all, the first condition is a fixed number of trials are conducted. I'd say that is met because we have exactly 4 cards being dealt. There's 4 trials. Each time we deal a card, we ask, is it an ace? Okay, step 2, is there only 2 possible outcomes, success or failure? Well, in this case, success is getting an ace. Failure is not getting an ace. So I would say condition 2 is met as well because each time we deal a card, we'd see, is it an ace? If so, it's a success. If it's not an ace, then it's a failure. Okay, condition 3 is the probability of success is the same on each trial. This is where we have to think carefully. On the first deal, we know there was 52 cards in the deck, so we were dealing out of 52. Remember, probability is likelihood of success divided by total outcomes. 52 total outcomes that could be dealt. Only 4 of them were aces, so my probability was 4 out of 52. In the second deal, I have not replaced the card, so instead of being a total of 52, it's 51 cards available. And then as I'm finding the probability, it depends on whether this first deal was an ace or not. If the first deal was ace, then one of the 4 aces is out of play, so the probability that I get another ace is now 3 out of 51. Or if first deal was not an ace, so for instance it was not an ace, there's still 4 aces in the deck, but 51 cards to draw from. Either one of these 2 cases, it's this case or the other, this is not equal to this or this. And as the probabilities are not all equal, we see condition 3 is not met. And if even one of the condition fails, we don't have to check the later ones. They all have to be true for binomial. So here we would say this is not binomial because the without replacement in this case of dealing cards means that I don't have the same probability per trial. So B is not a binomial distribution. So just as a quick wrap up, what we've talked about so far is this thing called a binomial distribution. What are the conditions to be binomial? And we've done 2 practice where we've had a situation and we've thought through, is this binomial or is it not binomial? Now let's assume that we can tell whether something is binomial or not, like we saw in the last two examples, or we know in some cases we might even be told in the example this is a binomial distribution. In either case, once we know we're dealing with something that's binomial, we have a special formula that will allow us to find the probability of each possible outcome x. So that's what you see listed here on the screen. If you know something is binomial, then we can use a formula to find the probability that x occurs. So x is a particular outcome for the random variable. And our possible values for x are 0, 1, 2, 3, 4, 5, 6, etc. So the probability formula is the probability that we would have x successes for our binomial is this. So this right here is a notation for the combination of in things choose x. Now in different textbooks or different notes, we might see the formula C of in choose x. So just be familiar those are the same things notation-wise. And we saw how to calculate that in an earlier lecture. Times the p, which represents the probability of success, raised to x as an exponent, times 1 minus p. Now, if p is the probability of success, then 1 minus p is the probability of failure. Raised to the n minus x, where n is the number of trials. So n is the number of trials, that's where it appears here, minus x. Okay. So these are where all these terms of the formula are coming from. Now, I do want to make a note at the beginning, before we even get started in the next example, in order to get these problems correct, you need to know how to use your calculator well. And you need to be patient and write out the problems and simplify each step until you're ready to type it into your calculator. I'm going to illustrate that here in this video, and I encourage you as you start these homework problems to start a good habit of working through the problems carefully and slowly, and then making sure you're patient and you correctly type things into your calculator. Because if you understand how the formula works, your most likely error will be calculator error for these types. So I know the formula is a bit new, but let's get into the first problem, and I think as we work through a few examples, you'll see where all the pieces come together. So it says the Pew Research Center recently reported that approximately 30% of internet users in the United States use Pinterest. Suppose a random sample of 15 internet users is taken. Use the binomial probability distribution to find the following. So with time, you're going to associate this as a pretty strong statement. When they say use the binomial probability distribution, that's giving us the permission to use this formula to calculate probabilities. And that's a big deal. So they said use binomial, so we were like, we can use this formula, we just have to use it correctly. Now in this formula, you see variables n, x, p. Could you pause the video now and off to the side, try to label what is n in this case? What's the probability that somebody's a Pinterest user? That's P. What is X in this case? So take a moment, pause the video, label, read through it again. What's N in this case? What's P and what's X? Unpause to check your work. So we know N always represents the number of trials. And in this case, it said 15 users were selected. So that's our pool that we're taking from, our pool that we're drawing from. So N is 15. Now, what is considered a success here? We're interested in how many people use Pinterest. So that's our success, people use Pinterest. And we were told 30% of people use Pinterest. So my probability, 30%, translates to a probability of 30 out of 100, which is 0.3. Remember, percent is part out of whole, so 30 out of 100, that's how we get our decimal 0.3. Okay. Now, in this particular part A, we're asked to find what's the probability that x is equal to 4. 4 of the 15 use Pinterest. So we've been told we can use binomial. We've identified the different aspects for this particular problem. So my next recommended step is to copy this formula right down here as it's written And then we'll slowly start to plug in the different values and simplify step by step. So the formula is the probability that we have. I'm going to write it in general, then I'll specify. The probability of x successes is the combination formula. I personally prefer to write it like this, so I'm going to write it the combination of n choose x times the probability where x is the exponent times parentheses 1 minus the probability whose exponent is now n minus x. Now this is the general formula. Specifically in our part A, we care about n is 15, so the combination of 15, select 4, multiplied by the probability of 0.3 raised to our x value of 4 times 1 minus 0.3 raised to the x value of n is 15 minus 4. Now let me quickly color code this with our coding that we see above. And now let's simplify step by step, because c parentheses 15 comma 4, our first term, that's a mathematical notation for the combination formula. And if you need to, you might need to look back a few sections previously in our notes where we listed out this formula. It says the combination of 15 things choose 14 is 15 factorial over 4 factorial times 15 minus 4 factorial. So that takes care of this first term simplified, partially. The next term, 0.3 to the 4th, that's really as simplified as it gets until I type it into my calculator. However, the next term, 1 minus 0.3, well, 1 minus 0.3 is 0.7. So I could more simply write that as 0.7 to the, okay, now 15 minus 4, that's 11. I've simplified that exponent. And I would say this term and this term simplified, we still need to work with this before we type it into our calculator for most people's calculators. If you have a fancier calculator, you could probably type it in as it's written now. But for my on-screen calculator, I need to do a bit more work before I can type this in. So 15 minus 4 factorial. This term, 15 minus 4 is 11, so this term is 11 factorial. And remember, when you have a factorial divided by another factorial, particularly large numbers, you're going to have a lot of cancellation, because what is 15 factorial? It's 15 times 14 times 13 times 12 times 11, continuing on until it gets multiplied down by 1. So as you can see here, I've kind of written out in general what's happening. And if this is unfamiliar to you, go back to our video where we discussed counting and combinations came up. We had a lot of examples similar to this, so you can see more practice. But what happens is the top becomes 15 times 14 times 13 all the way down until times 1. The bottom being 4 factorial is 4 times 3 times 2 times 1, multiplied by 11 factorial, which is 11 times 10 times 9, etc., all the way down. And we see there's quite a bit of cancellation. The 11 times all the way down to 1 is at the top, and it's at the bottom, and it's only multiplication, so those will cancel. So this first term here, 15 factorial over 4 factorial times 11 factorial, becomes 15 times 14 times 13 times 12 over the original 4 factorial, 4, 3, 2, 1, everything else canceled, times the 0.3 to the 4th times the 0.7 to the 11th. Now I think at this point each term is sufficiently simplified that we can type this into our calculator, so let's bring our calculator here. Now my calculator here has everything I need. One thing I would ask as you bring out your calculator that you plan to work with the course, let's verify you have everything you need. For our class, I think at minimum you need to have parentheses in your calculator. You need to have an exponent button. Now, my exponent button looks like this, what you see highlighted on the screen. Yours might be something that looks like this. This is the exponent, so you put the base exponent button and then type in the exponent, whatever that is. So that might be how yours looks. So you need parentheses, exponent button. Square root is helpful, although you can type that in as to the 1/2 power. of course, add, multiply, subtract, divide. If you can see here, this button E, that will also be needed later in the course. So E represents the infinite number that starts and can be approximated by 2.718. So make sure your calculator has all of these. If it doesn't, then I encourage you to go to any type of store that has some kind of school supplies or education center, and they have calculators that have all of these buttons for probably around $10 to $15. So as I type this in, the big thing is that we want to make sure that the exponents only go to the base that we intend to. The fraction is here separately, so I'm going to, in my calculator, or before I type it in, I'm going to make sure I've written in my parentheses so that I just have to follow exactly what I've seen. And a few notes on parentheses: whenever you're typing in a fraction to your calculator, unless you have a fancy calculator that automatically sets up the fraction top and bottom, if you've got that, you don't have to be as careful. But if you've got a calculator similar to my on-screen one, then I would encourage you to keep the top of the fraction in separate parentheses, division side, bottom of fraction in separate parentheses, okay? Multiplied by 0.3 to the 4 as an exponent, and then anytime you've got more than a single term in your exponent, I would encourage you to have parentheses around that as well. So I've written in every parenthesis I'm going to type in the calculator. So I just have to read here left to right and correctly type it. So I will start with parentheses 15 times 14 times 13 times 12. Close parentheses, that says the top is done, divided by parentheses 4 times 3 times 2 times 1, as it tells me, close the parentheses. Next, multiply by parentheses 0.3. It tells me close the parentheses. Exponent button, 4. Next, multiply by, open parentheses, 0.7, close parentheses, exponent button. Now, since my calculator is relatively simple, and I'm typing in the exponent 11, to make sure my calculator is having 11 as my exponent, I'm going to leave that in parentheses, so I'll say parentheses 11, close the exponent parentheses, and I can press enter. That is the probability. Now, we were asked to round to 4 decimal places here. So looking at this number, think about how would you round it to 4 decimal places? Okay, we would go off to the 4th decimal, 2, 1, 8, 6. Okay, 6 is the 4th decimal. You look one past it. If it's 5 or greater, round up. If it's less than 5, stay the same. It's a 2, so we stay the same. This is 0.2186. Okay, so we finished this problem, and it has taken some minutes, but do note that our initial setup was done in the first few seconds. The remaining part of the problem was just carefully executing the plan. After we did the setup, there was really no new critical thinking. It was just carefully, step by step, simplifying it until we could type it into our calculator. And that's really all there is to these problems. So for part B, it says we've got the same preamble as before. 30% of internet users use Pinterest. We had a sample of 15. And now we're curious, what's the probability that fewer than 3 of the people use Pinterest? Now, anytime you have these kind of verbal phrases of fewer than 3, more than this, less than this, I would encourage you to first take a moment and translate what that means in context. Fewer than 3 means exactly which values. Okay, first of all, when it says fewer than 3, that means don't include 3. It needs to be less than 3. So we know 2 is less than 3. 1 is less than 3. Is there anything else less than 3? Well, we could also have 0, because if it's the number of people who use Pinterest, the probability that fewer than 3 is the probability that 0 people of the group do, 1 person of the group does, 2 people of the group do. So we're interested in the probability that x is 0, 1, or 2. Now what that means is we're looking for the probability of 0 plus the probability of 1 plus the probability of 2. And each of these probabilities separately could be understood by this probability formula since it's a binomial distribution. Now, the difficult part of this problem is that we will have to do this calculation 3 separate times. So it will be a bit time consuming, but we can do the setup within a minute, and then we just have to carefully calculate it using our calculator. So let's talk about the setup. Since it's fewer than 3, we know 0, 1, or 2 are the acceptable values. Now, based on this formula that we see here, let's list out the formula for the probability that we have 0. We know as before, our total number of trials is 15. The probability of success, or being a Pinterest user in this case, is 0.3 for each trial. Now my value of x is going to vary whether I'm looking at p of 0, 1, or 2. For p of 0, x is 0. So following the formula, I have the combination of 15, 0 times the probability of 0.3 raised to the x value you're interested in, which currently we're interested in the x value of 0, times 1 minus 0.3. Now, with practice, you might mentally quickly say, well, 1 minus 0.3 is 0.7. I'm just going to immediately write that. Feel free to do so. And then raised to the 15 minus 0. So I'm just following the formula 15 minus 0 here. And again here, once you get used to the pattern, you might just mentally simplify that quickly so long as you're consistent. Now this represents the probability that 0 of the 15 users use Pinterest. There's a bit of simplification left, but the idea is there. Let's write out p of 1 together, and then I'll leave it to you to write out p of 2, and then all we have to do after that is done is simplify each term. Okay, so next up for p of 1, it's the same formula. N is the same, p is the same, except now our x value is 1. So it's the combination of, we had 15 things, we select one of them, times the probability, the probability is 0.3, to 1, times the probability of failure, 1 minus 0.3, which is 0.7, to the 15 minus 1. Now the pattern is, you might notice this, for the last exponent, it's always the larger number minus the number you're selecting here. So 15 minus 1, that's 14. That is our probability that 1 occurs here. Now I'd encourage you to take a moment and pause the video and try to write out for yourself, as we did with these first two, what represents the probability that 2 of the 15 people use Pinterest. And when you've done that, unpause the video to check your work. So pause now, write out the formula as we see above, and then unpause to check your work. So for probability of 2, it's a combination of 15 people select 2 times the probability in each case is 0.3 to the 2 times 1 minus the probability of success is 0.3 to the 15 minus 2. So at this point, we've set up all we've needed to. We've got the ideas down. All that's left is simplifying term by term and then finally calculating it. So I'd encourage you to, again, always have paper out, work through step by step, and only when you've simplified, type it into the calculator. So let's look at the first term. I'll zoom in there. As I simplify the first term, we know the combination formula says take the overall amount 15, that's at the top factorial, over the smaller number factorial, times larger minus smaller factorial. That's just the pattern for combination. Now one thing we want to keep in mind is 0 factorial is set to be 1. That's something discussed when we first introduced factorial. 0 factorial is 1. Now 15 factorial means 15 times 14 times 13 times 12, etc. down to times 1. 15 minus 0 factorial, this is 15 factorial when simplified. So I've got 15 factorial over 15 factorial. Those cancel perfectly with each other. And I'm basically left with 1 over 1, because when the 15 cancels, there's just a times 1 there. 1 over 1 is 1, so this term becomes 1. So I've got 1 times 0.3 raised to the 0 as an exponent times 1 minus 0.3 is 0.7. 15 minus 0 is 15. So that's how the first term simplifies term by term. Now that I've got that simplified, let's move on to the second term. Once we have all 3 terms simplified, we'll type it all into our calculator and get our probability. So the next term is the combination of 15, 1 times 0.3 to the 1 times 1 minus 3.3 raised to the 15 minus 1. I'd encourage you now to pause the video and attempt writing this out simplified as we did with the last one. Unpause to check your work. So we know with the combination formula that's 15 factorial over 1 factorial times 15 minus 1 factorial. Now 15 minus 1 factorial, that becomes 14 factorial. And we know when I've got a factorial over a factorial, which happens when we use the combination formula, the two larger factorials are going to have a lot of internal cancellation because the top is 15 times 14 times 13 all the way down to times 1. The bottom has 14 times 13 times 12 all the way times 1. Basically, the top and the bottom have the exact same terms 14 downwards. So the 14 downwards are all going to cancel. And this becomes basically just 15 over 1 factorial. Now I'm doing this a little faster because this was talked about in a previous lesson in more detail. If this is fuzzy to you, go back to that lesson, review how we simplified combination formulas. So this entire formula here becomes 15 over 1 factorial, which is 1, which is just 15. Okay. So my plus here will become 15 times 0.3 to the first times 0.7, 15 minus 1 to the 14th. So that's how that second term simplifies. Okay. Now let's talk about our final term here. As we simplify this, again, I'd encourage you right now, pause it, attempt on your own. For guided practice, unpause to check your work. So the combination formula says take the larger number 15 factorial over smaller number factorial times larger minus smaller factorial. 15 minus 2 all factorial is 13 factorial. We know larger factorial over other larger factorial, this is going to have a lot of cancellation. Specifically, the 13 factorial will cancel with the 13 factorial that's embedded in the 15 factorial till we're just left with 15 times 14 over the 2 factorial that was untouched below. So this will become 15 times 14 over 2 times 1. So this was kind of our scratch work. Now we're simplifying it, times 0.3 squared times 0.7 raised to the 13th. So now that we've simplified each term by term, let's zoom out and see the entire sum. All I have to do to finish the problem is type this carefully into my calculator. These three things multiplied together. Now, I'm going to illustrate how you can type it in all at once. You might prefer to type it in term by term and then add them all together. I'm going to make any notes in terms of parentheses that I need right now before I start getting my calculator. For instance, here in the second term, I see my exponent has two terms in it, 15. If it's greater than 9, I'd encourage you to offset it in parentheses at the beginning. Remember, what you write down, you're likely to type into the calculator. So it's just a way to increase your accuracy. I just erased the scratch work so there was less crowding our page. Here the 14 also has a two-term exponent I'm going to leave in parentheses. Same with the 13. Also, I see I've got a fraction for this third term, so I'm going to say top in parentheses divided by bottom in parentheses. And looking, I don't think there's anything else that I need to make sure I add. So now I just carefully type this into my calculator. Now just a quick note, remember the main thing is for you to make sure you know how to do this correctly, not just watch me do it correctly. So I would encourage you to make sure you're following along in your own calculator and see if we get the same answer. Because if we don't, you need to identify that now so that you can correct it maybe as we do our next example, see what's going off before you get to the homework problem. So don't just watch me type this into the calculator, follow along with your own, even if it means you need to pause the video to find your calculator. So here I'm going to say 1 times my parentheses, I'm just copying exactly what I see written on the page, 0.3 exponent to the 0 times parentheses 0.7 close parentheses exponent parentheses for my 15 close the exponent for or the parentheses for the exponent plus reading left to right 15 times parentheses 0.3 exponent 1 times 0.7 close parentheses exponent parentheses 14 close parentheses for exponent plus parentheses for the top fraction 15 times 14 close parentheses Continuing, dividing by the 2 times 1, close parentheses, times 0.3, close parentheses, exponent 2. Finally, 0.7, close parentheses, exponent parentheses 13. My on-screen calculator is frozen. We've walked through how to do it. Let me quickly recalculate it and we'll see the final answer on the screen. And whenever we type that into our calculator, we should get 0.1268277. We were asked to round to 4 decimal places. So here we count to the 4th decimal. That's our 8. You look 1 past it. If it's 5 or greater, round up. If it's less than 5, stay the same. It's a 2, so we stay the same. So rounding this, we should get a probability that we have fewer than 3 people using Pinterest is 0.268. So that would be 0.1268 as our probability here. Now the important thing after we finish a problem that admittedly did take a bit of time is we make sense of what took the time. The initial setup, once you get used to the formula, we were able to complete within a few minutes. The remainder of the time was spent carefully simplifying that formula term by term, making sure we don't introduce errors until we were finally able to calculate it and get our final answer. So as you work through these types of problems, you need to think about 2 things. First, do you understand just the setup of the formula? That's the first thing we need to meet. Once you understand that, are you confident that you can simplify term by term until you get to a simplified version like this, that you can then, third step, correctly type into your calculator? So as you're working through the homework, if you find that you're having issues, try to identify which of those steps is giving you the issues. Is it the initial setup? Is it the simplification? Or is it typing it all into your calculator? Now for C, it says for the same setup, it's our binomial distribution. We had 15 people surveyed, 30% of people in general use Pinterest. Find the probability that more than one person uses Pinterest. Now this phrase of more than one person, in the context of our problem where we had 15 people sampled overall, what does more than one mean? What are acceptable values? So more than one means must be greater than 1. So first number that we're interested in greater than 1 is 2. Anything greater than 1 is okay, so 3 is also okay, 4 is also okay, 5 is also okay, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now consider, is 16 okay? 16 is greater than 1, right? But it has to be in context. If you look back at the original paragraph of the problem, so a little bit above this page, it said that we were surveying 15 users in all. So I've got to be more than 1, but less than or equal to 15. I can't have more people than were surveyed. So that's why we stop our list at 15. 15 is the last value that's more than 1, but still within the limits of our survey. Now, our last example had us calculate the probability for 3 separate options, and it took quite a bit of time. Do you think it would be an enjoyable use of your time to calculate the probability for these 14 different options? Okay, first of all, we'd have to write out all 14 options. That would take maybe half a page, then term by term simplify, and then after we've hopefully correctly simplified each of the terms, correctly type it into our calculator. It would take an inordinate amount of time. That would be the direct approach. Now, if you think back to some of our earlier lectures, particularly when we were talking about probability and counting, we said sometimes if the problem they're asking you to do would just take too much time, ask yourself if there's an indirect way to solve the problem. This would be too complicated to calculate directly, so I'm going to kind of do the backdoor approach. Instead of directly facing the problem, let's solve it in a different way. We know the probability of all possible users using Pinterest, so the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3, all the way up to the probability of 15. So basically, that's the probability of any possible outcome. The total probability of all possible outcomes must equal 1. And this was initially introduced in our videos about probability and solving problems with probability. Now, what are you particularly interested in this problem? You're looking for this grouping, highlighted here. We don't want to find this directly, but instead, what if I subtracted this grouping from both sides? Then I would get the equation p of 0 plus p of 1 is equal to 1 minus, or excuse me, I said it wrong. I said subtract what we have here highlighted, but instead I want to isolate this. I don't want to move it. I want to get everything away from it. So let me clear the page there. Let's now get what's highlighted by itself, and we'll subtract a p of 0 minus a p of 1. What's done to one side must be done to the other. It perfectly cancels from this side, where we're only left with the term we're interested in. From the other side, we have 1 minus p of 0 minus p of 1. So the idea here is you can find the probability of 2 users plus the probability of 3 users plus all the way until you get to the probability of 15 users as equal to 1 minus probability of 0 minus the probability of 1. Now, the reasoning behind this, again, like I mentioned earlier, is from an earlier lecture. If this is unclear to you, go back to our lecture that talked about probability and the not statements. And you can watch a few different videos, work through some problems. This reasoning should make more sense after reviewing that. But the idea is once we have this reasoning, if I want to find the probability that more than one person uses it, I could either find it directly on the left side or the right side. I could say, let's find the probability 0 people use it minus the probability that one person uses it, all from 1. So 1 minus probability of 0, 1 minus probability of 1. And at least for me, this is the approach I'm going to take here because it's much simpler. Okay, so let's write that out. We need our binomial formula for the probability of 0. Subtract that from 1, and then from that, subtract the binomial that we have got the probability of 1. So here I'll have my 1 minus, now the probability that we've got is 0. Following the formula is the combination of 15 things, because we have 15 in total from the paragraph above. Choose 0 times the probability of success, which we saw earlier is 0.3 to the 0, times 1 minus 0.3. I think we can simplify that just in our heads to 0.7, to the 15 minus 0. We could have also just simplified that immediately to 15. Now we follow the formula, that's 1 minus the probability of 0. We now subtract the probability that we've got 1 case, so that's a combination of 15, choose 1, times the probability of 0.3 to the 1, times 1 minus 0.3, which is 0.7, to the 15 minus 1, or you could immediately simplify that to 14 as the exponent there. So the main idea, the critical thinking part is done. We just have to carefully simplify each term until we're ready to type this into our calculator. So I'm going to write out exactly what we need typed in. So 1 minus, now the 15 choose 0, we actually already calculated that above, and we saw that was 1, so let's not reinvent the wheel. We'll copy that down as 1 times 0.3 to the 0 times 0.7 to the 15 minus 0 is 15, minus the combination of 15 choose 1. Again, we already calculated that earlier. That was 15, so I'll just recopy that down, times 0.3 to the 1 times 0.7 to the 14. Before I type it in the calculator, I look and I see, is there any parentheses that I should add to increase my accuracy of getting the correct answer? And out of habit, any exponent that has more than one digit should usually be offset in parentheses, so I'm going to add that here, because if it's written on the paper, I'm more likely to remember to type it into my calculator. And now let's type this in all at once. I would encourage you to pause the video now, type this into your calculator, unpause to see if we get the same answer. So here I'm typing in left to right, 1 minus 1 times parentheses 0.3 exponent 0 times parentheses 0.7 exponent include in parentheses 15 close parentheses minus 15 times parentheses exponent 1 times parentheses, 0.7, close parentheses, exponent, parentheses, 14, close parentheses, enter. And here we get 0.96473 continuing. We know it said round to 4 decimal places, so that's 9647. Look past it. 5 or greater round up, less than 5 stay the same. It is less than 5 because it's a 3, so we stay the same. So rounded, this is probability of 0.9647. So that would be our probability for this one. Now our final one here is written below in D. This is our final subpart to this problem. So we still have the same situation as before. 30% of internet users are said to use Pinterest. We had a simple sample of 15 internet users, and we were asked now to find the probability that the number of people who use Pinterest in that sample of 15 users is between 1 and 4 inclusive. Now anytime we have a phrase like this, we know we first step need to translate what does that mean in hard numbers. So what does 1 and 4 inclusive mean? What are acceptable values? Well, inclusive means you can include the endpoint, so that means you can have 1. And between 1 and 4 are the numbers 2 and 3, and since it's inclusive, I can include 4. So basically, they're looking for the probability that you've got 1, plus the probability that you've got 2, plus the probability that you've got 3, plus the probability that we have 4. Now, how do you calculate probabilities? Well, sometimes, if it's a simple enough problem, we know probability is number of ways what we're looking for could occur divided by total number of ways. But actually in this example, we have a shortcut because we know that it's a binomial probability distribution, which means the probability follows our very specific formula mentioned in the box above in the upper part of this page of notes. So with that in mind, to calculate the probability of 1, we just plug it into the formula, plus plug in the formula to get probability of 2, plus plug in the formula to get probability of 3, plus plug in the formula to get probability of 4. Now we've done this type of problem in the previous 3 examples. All we're doing is additional practice. The ideas are the same. I would encourage you to right now pause the video and attempt writing out what P of 1 is, what P of 2 is, what P of 3 is, what P of 4 is. Now, so you can check your work step by step, on this first pause, just write out what each of those 4 terms would be. And then once we've verified that you've got the right thing written down when you unpause, the next pause, I'll have you simplify it. And then after that, we'll calculate it. So if you would, pause the video, write out what each of P of 1, P of 2, P of 3, P of 4 is from the formula. Unpause when you've written that out. So let's check what you have written down so far. The P of 1 term is what we have listed here. It's a combination of 15 choose 1 times 0.3 to the 1 times 1 minus 0.3, which is 0.7 to the 15 minus 1. Okay, P of 2 is next. C of 15 comma 2 times 0.3 to the 2 times 0.7 to the 15 minus 2. You could have also just quickly simplified that to the exponent 13. P of 3, C of 15 choose 3 times 0.3 to the 3 times 0.7 to the 15 minus 3. And then finally, P of 4 is the combination of 15 choose 4 times 0.3 to the 4 times 0.7 to the 15 minus 4. Now, if you got that correct, great. If you didn't get that correct, that means you need to practice going from the details of how the problem's listed and translating the verbal description of the problem into using this formula. Now, if we agree on this part, the next step is simplifying each term by term. Specifically, what do we probably need to simplify? You need to simplify the combinations. Some of these you've already calculated. Feel free to just reference that. But if it's one we haven't found before, you do need to find it using our combination formula. For me, I need to simplify what is 15 minus 1. What is this? So these would be the things I need to simplify based on how I have it written. So I'd encourage you to now pause the video and do the simplification step. Unpause to check your work, and then finally I'll ask you to pause again to do the calculation step, and then you can uncheck your work. Unpause to check your work. So here, working left to right, I knew from earlier, you can see what I've highlighted here on the screen from earlier, we found the combination of 15 choose 1 is 15, so I'm just going to recopy that here. Similarly, I looked back at an earlier problem, and in this earlier problem, I found 15 choose 2 was 15 times 14 over 2 times 1, so I'll just copy that down as well. Now looking back, we haven't calculated a 15 choose 3, so I don't have a shortcut there. I'll just have to calculate it directly. I'm going to do my scratch work up here. So my page is uncolored. I have 15 factorial over 3 factorial times 15 minus 3 is 12 factorial. I know the 15 factorial over 12 factorial, that will cancel to leave me with a 15 times 14 times 13 on the top over a 3 times 2 times 1. All the terms 12 factorial canceled with the 12 times 11 at the top from the 15 factorial. So that will be 15 times 14 times 13 over 3 times 2 times 1. And then again, we haven't found the combination of 15, 4 already, so we will have to calculate that again from scratch as well. And that is 15 factorial over 4 factorial times 15 minus 4 is 11 factorial. Now I know the 15 factorial over 11 factorial cancels, so we have 15 times 14 times 13 times 12 on the top, and then the 4 factorial from before. Okay, so that's what replaces this term. And then little by little, we've simplified each term. We've almost got to the calculation phase. The last thing I would encourage you to do is just glance and see, is there any parentheses that you should add to help increase your accuracy when you type it in? Again, parentheses you should look for is in fractions. Make sure the top is kept in parentheses, divided by bottom in parentheses. Exponents, anything with more than one digit should have parentheses. Particularly if you have a calculator that's on the simpler side, like my on-screen one is. So I'm going to put the 14 in parentheses, the 13 in parentheses, the 12, the 11. If it's not written, I'm less likely to actually include it. And then I would type this into my calculator carefully left to right. I would encourage you to pause the video right now, type this into your calculator, unpause, and when you unpause, I'll have the answer on the screen so you can verify if you got the correct answer. And this is testing your calculation ability. So when you calculate it, you should get this number here, 0.51074, rounded to 4 decimal places. That's 0.5107. And that's the end of this problem. So remember this problem, we broke it down step by step. We said first, can we set it up? Then can we simplify term by term? Then can we calculate together? So if all those 3 worked out for you, that's great. Continue practicing as you do the homework. If any one of those was a problem, identify which one, and then go back in the video previously and watch it where we explained it in more detail and try to make sense of that. You can also look at examples in the textbook. Let's look at our final topic of this section of notes. So if we know we're dealing with the binomial random variable, either because the problem statement told us it was binomial or based on our 5 conditions we were able to check and verify it was binomial, then we can find the mean, variance, and standard deviation for the binomial random variable with the formulas listed below. The mean, which we know we write with our symbology mu sub x, is the number in trials times the probability that each trial is a success. The variance, sigma sub x squared, is the number of trials times the probability rate times 1 minus the probability rate. And remember, in the binomial, there's only success or failure. So if the success is p, then 1 minus p is actually the failure probability. And then we know between variance and standard deviation, if you take the square root of the variance, you get the standard deviation. So the square root of this is our standard deviation. Now keep in mind, as you're looking forward to the test over this chapter, you are allowed, as before on each single test, a single personal formula sheet. And I would particularly look through these chapters and make sure you write down all the relevant formulas so you'll have it needed and organize it. Don't just say it's the mean, say it's the mean formula for the binomial, the variance formula for the binomial, standard deviation formula for the binomial. So have it labeled, it's the variance of what, standard deviation of what. So keeping these formulas in mind, let's look at our next example. So a poll is conducted, and 81% of the respondents to the poll said their jobs were sometimes or always stressful. 10 workers are chosen at random. all our answers we should round to 4 decimal places, so we're asked what's the probability that exactly 7 of them find their job stressful? Now here, if we think through our 5 different conditions for a binomial distribution listed in the first page of this section of notes, we can see that this is a binomial distribution. And since it's a binomial distribution, we know we can use the formula that the probability that x occurs is the combination of the number of trials, choose x, times the probability of success to the x power, times 1 minus the probability of success to the n minus x. Now here we care about exactly 7, so for us this will be the probability that we have got 7 is combination of 10 workers, choose exactly 7, times the probability 81% said their jobs were sometimes or always stressful. That's 81% is part out of 100. 81 divided by 100, type that into your calculator and you'll get a decimal probability of 0.81. So that's 0.81 to the 7 times 1 minus 0.81 to the 10 minus 7. Now we know the first part is the setup. I need to then simplify term by term, and then I can type it into the calculator and we'll get our answer. The combination formula is here 10 factorial over 7 factorial times 10 minus 7, which is 3 factorial. We look at the larger factorial at the top, larger factorial at the bottom. There's going to be a lot of cancellation there. So this entire term will actually become 10 times 9 times 8, 7 and below cancel, and we've still got the 3 factorial below 3 times 2 times 1. And then we have got our 0.81 to the 7 times 1 minus 0.81 is 0.19. 10 minus 7 is 3. So simplifying that and then writing in our helpful parentheses, top fraction in parentheses, bottom part of the fraction in parentheses. None of my exponents have more than one term, so I don't have to include parentheses there. I'm going to correctly type this into my calculator, round it to 4 decimal places. And when we type this into the calculator and round to 4 decimal places, you should verify on your own, but we will get, when rounded, 1.883. For our answer to part A. Now the next problem, what's the probability that fewer than 5 find their job stressful? Take a moment and think through what would be the verbal description of how you solve this problem step by step. What would you do first? Then comes what? Then comes what? Okay. Fewer than 5. That's the type of phrase that we say, hold on, I need to translate that in context. Fewer than 5 means less than 5. But in context, since we're talking about the 10 workers chosen, the fact that fewer than 5 find their job stressful, how many possibilities are there? Well, you could have 4, that's fewer than 5, 3, 2, 1. Am I missing anything? Yeah, 0. Remember, 0 people could have responded that they find their job stressful. So fewer than 5 means we're looking for what's the probability of 0 people finding their job stressful, plus the probability of 1, plus the probability of 2, plus the probability of 3, plus the probability of 4, plus the probability of 5. Oh, and I just realized I misspoke there. I should not include plus the probability of 5 because it did say fewer than 5, right? It wasn't less than or equal to 5, it was fewer. So it would stop off at the probability of 4. So we need to correct that misspeak there. Now we know that's just the general outline. Finding the probabilities follows our binomial probability formula, so I need to have 4 different calculations of that. So we'll list it out first, just in general, get the main idea from the formula, then simplify term by term, then type it into the calculator. So I'd encourage you to right now, pause the video, and practice writing out exactly what is P of 0, plus what is P of 1, plus what is P of 2, P of 3, P of 4, unpause to check your work. So just following straight from the definition, we would get this. Next term is simplifying, so we'll simplify term by term. The biggest part here generally is simplifying the combinations. You might prefer to do that off to the side, so I'm going to quickly off to the side figure out what is C of 10 choose 0, See if 10 choose 1, and then I'll replace that there so I'm not taking up my limited space here with scratch work. We know that combination of 10 choose 0 is 10 factorial over 0 factorial times 10 minus 0 factorial, which is 10 factorial. The 10 factorials cancel and you're left with 1 over 0 factorial. 0 factorial is 1, so this is 1 over 1. So that becomes 1 times 0.81 to the 0 times 0.19. 10 minus 0 is 10. So that's how the first term simplifies. Okay, next up, combination of 10 choose 1, that's big number factorial over small number factorial times big minus small. 10 minus 1 is 9 factorial. We know that the 10 factorial over the 9 factorial will cancel together till we're only left with 10. 9 and below cancel. 1 factorial is 1, so this becomes plus a 10 times 0.81 to the 1 times 0.19 to the 9. Now just a small thing to check. I haven't mentioned this earlier, but a good way you can check your work, it's not the only indication you're right. You need to make sure you've done it correctly, but one indication is these two exponents should add up. 1 plus 9 is exactly the number of trials, 10, and that should work in each of them. So for instance, here the first pairing of exponents 0 and 10 does add to give you 10. 1 plus 9 does add to give you 10, so that's one thing you should check. They should at least add up to give you the number of trials in each separate term. Next, the combination of 10 choose 2, bigger number factorial over smaller number factorial times bigger minus smaller. That gives us 8 factorial here. We know 10 factorial over 8 factorial leaves 10 times 9 at the top divided by 2 times 1. So we'll now replace that. And 10 minus 2 is 8, so that's what our final exponent is there. So next up, combination of 10 choose 3. We've got bigger number factorial over smaller number factorial times bigger minus smaller. 10 minus 3 is 7 factorial. 10 factorial over 7 factorial cancels to give us 10, 9, 8, 3, 2, 1. That's all we're left there. We'll replace that in our list above. And our final combination to simplify, combination of 10 choose 4, bigger number factorial over smaller number factorial times bigger minus smaller factorial. 10 factorial over 6 factorial cancels 10, 9, 8, 7 over 4 times 3 times 2 times 1. We'll replace that in our list above. And here we've listed out the entire expression simplified term by term. So we know if we've gotten to this point, all that's left is to carefully type this into our calculator. I would encourage you to pause the video right now, type this into your calculator, and then round to 4 decimal places, unpause to check your work. So when we type this into our calculator, we will get 0.00487. Continuing, we need to round to 4 decimal places. So our 4th decimal is the 8. 1 past it is greater than 5, so we're going to round this up to 0.0049. So we have worked through a handful of these problems using this binomial probability formula. I think we can see that with these, it's the same process each time, but where we really need to be careful is in simplification and correctly typing this into the calculator, because there are many opportunities for error. So I'd encourage you to practice this, and as always, work it out on paper. Give yourself space. Don't write up in a cramped amount of a corner. Get a new piece of paper out and have plenty of room to work through your answer. So this next problem, remember, we already identified this is a binomial random variable. And as it's a binomial random variable, we have some specific formulas we can use. So when it asks us, what's the mean number of individuals who find their job stressful, we can look back at our list here. The formula for mean of a binomial distribution is the number of trials times the probability of success. So we can copy that formula down. And for us, if we look back at the description of the problem, it said 10 workers were chosen. We knew our Number chosen was 10, so this is specifically 10. The probability that any trial would be successful is 0.81. Multiplying that together, we get a mean of 8.1 workers would say their job was stressful, sometimes or always. So next up, what's the standard deviation of the number who find their job stressful in a sample of 10 workers? Take a moment to look at the top of this page and write down the relevant formula. What formula represents standard deviation along with the notation we use to describe that? That would be sigma subscript x is the square root for a binomial distribution of n times p times 1 minus p. For our particular problem, that's the square root of 10 times 0.81 times 1 minus 0.81. Simplified, that's 10 times 0.81 times 0.19. Let's type that into our calculator, and we'll round to 4 decimal places if needed. So when you type this into your calculator, you should get 1.2405 continuing, rounding to 4 decimal places. 5 is the 4th decimal place. Look one pass. 5 or greater, round up. Less than 5 stay the same. It is a 6, so we round up. So we should round this to 1.2406. Is the standard deviation for this particular problem. So that's all there is to this lesson. My parting reminders to everybody is to 1, work out the problems in plenty of space on your blank paper, have the formulas handy, take your time, simplify term by term, and when you're ready, type it into your calculator carefully. So as you have any questions as you work through these, remember you can contact me through our campus communication and I'll be happy to help you.